Like this one. Wow. See? Get very accurate system. You see 1 point something. You see this one. Let's say if I want to show only for some significant digit, let's say I want to put 4 significant digit. เลขนี้สำคัญ 4. We can do this one by comma and 4. Okay, comma and 4. Now you have this one. This one. Okay, this one. See? And the system is stable, right? See? Okay. Another way to do this one, you see, you put VPA, comma, for significant digit, just for this line only. If there is another way to do it, if you say, I want the whole problem to be controlled by some certain significant digit. Okay, for example, let's say I add this one. Let's say I add digit 4. Digit 4. I can get rid of this one. I put digit 4 here. And I deleted comma 4. Okay? Just leave only VBA. Now, you see, the less from this one, if you use VBA, they convert only to 4, this is 4 significant digits only. Okay? There's another way to do it. Okay? Okay, digits 4. Okay. 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 Is there any question? Another one, this is another problem. You have this one. Okay? You see, you want to solve this one. Okay, homogeneous solution will be this one. Right? And that's square plus 4, and yeah, plus 4. You see, right? Now you have this one minus 4. Right? This one is minus 2. Right, this one. Okay? So in that case, your Y homogeneous solution will be what? C1 e to minus t, right? Plus C2 t e to minus t, right? In this case. Right? For this one, if input is a constant, normally this one we can assume yp equal to a. Substitute this one, solve for a. Right? In this case is 4a equal to 16, right? So a equal to 4. Right? So the solution will be plus 4 here. homogeneous y particular. Okay, this one, right? This one. Okay, this one as well. This one. Okay, now this one, you see, we have this one. Okay, this one. I said you have this one, lambda square plus 4 equal to 0. Characteristic equation. Right, this is one. This one is what? Minus plus 2i. Right? So in this case, alpha is 0. If you say alpha plus minus delta j, right? So this alpha will be 0, right? Okay. So our y solution, yp solution, y homogeneous solution, C1 cos 2t plus C2 sine 2t, right? This one. Because e minus t will be equal to 0. This one. So your solution will be this one. Okay, and by particular solution in this case, because it's constant, yp will be equal to a. Substitute this one to this one. You can know that a will be equal to 0.5. Right? And your solution will be C1 cos 2t plus C2 sine 2t plus 0.5. That is solution. This one, if you have output, this input is t, one particular solution will be at plus b, right? And you need to find a and b from this one. Okay, so this one. Okay. Okay. So this one will be assignment number 4. Okay. Okay. Now we come to see some application for this one. Okay, so let's say you have we call spring and mass. Okay, spring and mass here. Let's see if you have this one is equilibrium point. Equilibrium point. Okay. Okay, if you want to find then we model this one, right? You measure x from the equilibrium, Okay. So in this case, you have this one, right? And you have spring here, kx, right? We have no input. No external input, right? So in this case, you can have summation force equal to MA or MA lambda. Force will be equal to, if this one is plus force will be equal to Kx, right? K is a spring constant. Right? And this one, moving this one, so I get a 1, let's say. 1. So this one My. So you have this one. See? This one, no external input, right? See, no external input. Right? No external input. So if initial condition, let's say y0 and y.0. If y0 equals to 0 and y.0 equals to 0, what is the solution of this one? y0 equals to 0, y.0 equals to 0. What's the solution of this one? Y. Can you say? Can you tell? Common sense. Look at this one. If this one is equilibrium, right? It's in no motion, right? Right? As per spring, this one, and you attach mat, this will be expand. S0, right? The previous spring, no force, right? No mass, right? It will be over there, that one, unstressed spring, right? If you attach mat, if we drop down to this one, right? Drop down, right? So actually this one, Ks0 equal to mg, right? Right? K is low equal to mg. Right? See? So it already stretched out mg. That's why I don't have mg here. Right? You don't have mg here. Right? Because of it's already expanded this one. We measure from this, not from this. We measure from this. Okay? Okay. Okay, so we have this one. So if it's stationary here, equilibrium here. Equilibrium it means no motion. Over there is no motion. If no external force, it means that it's still there. Right? Initial condition is 0 as well, right? So it's still there. The solution will be y equal to 0. Right? So y will be equal to 0 in this case, if this one is 0. It's moved only if you give the initial condition. Right? Okay? So this one is only what? Initial response. We got initial response. Sometimes we got initial response. It's a response when initial condition with initial condition, right? So let's say you want to solve this one. You have this one. You see, as a similar problem, right? You have this one. See, the previous example, right? I mean, as I mentioned before, right? The last problem, we have this one. Imaginary part, only imaginary part. Real part is 0, right? Okay. See? Right? This one. A and B, what? Can be defined by initial condition. right? Let's see. Right? Okay, it can be found by initial. Let's say if y0 is 1. Let's say if you stretch this one to 1, and velocity here is 0. Okay, velocity here is 0, right? And if you release it, boom, it will go to this one. This one will go to this one. Right, this one. Yeah, this one. You solve this one, you have this one. In this case, you can also return this one in terms of cos omega n t plus base or yt sine omega n t plus base 2. You can also return this one to this one. Have you written this form? This one also. This one will be written this form. You know how to write this one. You know how to derive this one.
Yeah, we just expand the cos A plus B.
It's good. So you have this. This is solution anyway. Okay, so let's this one. If you have phase, it means you have some delay actually. Have some delay. Okay. So in this case, you have this one. Okay, what happened? What happened? อันนี้ไม่มีนะไม่มีในหนังสือต้องจดเองนะนั่นเป็นข้อสอบเลย You have this one. Let's say if I add damper here. Add damper. I have damper here. This A, this C, this mass X. What happened to this one? What's the differential equation for this one? Let's say you have this one, right? Mass, if x this one, right? So this one will be kx. This one will be cx dot, right? X is this one, x position this one, right? This one also we don't have mg. Because in X measure from equilibrium point. Okay, this one. So in that case, you're going to have this one. Summation F equal to MA. So you have this one minus KX minus CX dot equal to MX double dot, right? So in this case, you have MX double dot Cx dot Kx equal to 0, right? This one. Similar to this one, same, right? X not equal to 0. So this one move because of initial condition. If initial condition is 0, it means solution will be trivial solution X equal to 0. Right, this one. Okay? Okay. You see it before, right? You see it before, you have this one, right? You did it before. Right, this one. M1, M2, right? This is before. You have F here. You can find more of this one. X1, X2, right? You see this one before, you saw it before. You can try it. Okay. Okay. one. Okay, next. Now, I go to another type of equation. We call Euler-Cauchy equation, right? Look at this one. There's a particular, this one. Okay, this one. This coefficient not constant. Is a linear. Anyway, this one is linear. Right? It's a linear. But the coefficient is a function of x, this one. This one is x domain, right? X domain. If in time domain, maybe it can be written in this form, t square y double dot. If time domain, t square y double dot plus at y dot plus by equal to 0. This form in T domain, this is X domain, this form. How to solve this one? It's a linear. But X dependent, same as this one is time dependent, time vary. Above that the X vary. This one is time vary. Okay. Normally time vary is difficult to solve. Okay, but it's a special form. This one. If you see this form, we normally assume our solution will be this one. Same as this one. Assume y solution will be this form. Okay? Similar to previous one, right? And you see, we need to find m. M like lambda 1, 2, 3, right? M, so that m we have m1, m2, m3. In this case, second order we have m1, m2, 2m. Okay, second order. Okay, so we just substitute this one. Let's see, you see, if you have y, assume this solution. Okay, you substitute this one into this equation, right? And you have this one. Okay, so you just eliminate this one out, this one out, this one out, this one out, right? Okay, you have this one. Similar to previous, right? Lambda square, whatever, right? Similar form. Okay, we call this one is characteristic equation. We call this one characteristic equation. Similar, there are three cases. M distinct, M repeated, and M consecutive. Similar. Right? For this one, you see, for this, if a minus 1 square greater than 4b, right? We have distinct root. This one distinct. 2 distinct root. Right? If a minus 1 square equal to 4b, we have 2 repeated root. One repeated root. Okay? If a minus 1 square less than 4b, we have common conjugate. Okay, similar. Okay? So your solution will be like this one. See C1 x m1, C2 x m2. Okay? If x m1 over x m2 is not constant, it means that x m1 and x m2 are independent, right? Similar to the previous one. Okay? Case 1, 2 distinct root. Case 2, complex conjugate. Right? Complex conjugate. So your solution will look like this one. This one. You see, a little bit more complicated, right? This one. C1 x alpha, C2 x alpha, sine beta log x, cos beta log x, sine beta log x. This is the solution. Okay, this is the solution. Okay. You better remember as well. If you doesn't want to rely, this one you can remember. You can remember. Okay. That one is for complex conjugate, right? The other one for repeated root. Okay, ux similar to previous one, right? u2 is equal to ux plus y1x. Substitute this one, you can have this one. Okay? So your solution will be this one. And you have this one, so you have this one. Instead of t, right? Previous t, now we have log x instead, or log t instead. Right? See this one. Okay, this one is for repeated root. For repeated root. Okay? Okay, so you have this one, find a general solution for this one. See? First of all, you substitute y equal to x to the n, right? And substitute this one. And you obtain this characteristic equation, right? You have this one, right? So this one, yeah. So your solution will be this one. Will be this one. Okay, look at this one, it's unstable anyway. Look at this one. Okay. Okay. Have this one. If you have initial condition, this one. You substitute this one, so this is the solution. Okay, for homogeneous solution, this one. Okay, so if you have this one, this equation, this one, you substitute. You have this one. Okay, you substitute y equal to xn. Okay, and you can get this characteristic equation. So m will be equal to minus 3 and minus 3, right? So your solution will be C1x minus 3x plus C2 log x, x minus 3x, right? You can combine this one, you have this one. Okay. This one also you see x squared. This one. Right. So you substitute, you have this one. You have this one. Okay. If I have this one, if I change this one to this one, if I change this one to this one, can we use the same technique to solve? No. No. Okay. Yeah, you cannot assume that y equal to xn. No, not this one. It's not the same form. Okay? Okay? So the form that you need to solve have to be this one. Have to be this one. Look at this one, you see? X squared, x, and dx, this one. Okay? That's a form that applicable for this one. Okay? Okay. 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 So I have this assignment for you to do. Okay, this one, especially this one, the third assignment here, as I explained this morning, right? This one, you have to do it, and you have to submit your solution within next Thursday in class. So you can do it because you have prepared before. It's like in class quiz anyway. Okay? It's like in class quiz anyway. You can do this one. Okay? Okay. Follow the instruction then. Is it possible to solve by using direct integration? Okay, or not? Okay, if not, is it applicable for exact equation? No integral factor. I don't like that one. Use this one. Okay, exact equation. If not, is it try to use MATLAB symbolic toolbox? If not, try to use this one. Numerical solution by using ODE 45. Actually, there are more than this one, and also you try this one. This one use forward Euler approximation as explained last week. Okay, so you have to be here.
So for one problem, we only use one of the methods.
Have to have in follow.
Okay.
Start the first one first, but I persuade you to do all the method. I persuade you to do all the method. But sometimes in exam, if you say like this, you have to try that one. Okay. For example, let's say if you have problem number one, this one. If it can be done by using direct integration. Okay, if it can be done by using direct integration, and you say you cannot do it, you can do with this one. Let's say, in that case, instead of 10, you got only 3 points. Okay, something like that.
We follow.
Yeah. In order this one. So let me. I think it's better to do all of them. Okay? It's better to do all of them. Right? Okay? For example, this is let me show you this one. I'm sorry. Okay, in this one, let's say, yeah,
Was I can quickly submit on the Word form?
yeah, Word and convert to PDF file.
Yeah, sorry.
Okay, for example, this one, I have this one. Let's say I have this one. I try to do direct indication, right? Direct indication, right? I have this solution. Let's say I have this solution. Okay. How can we sure that your solution is correct? Yeah. How can we sure that your solution is correct? รู้นะผมจะถ่ายรูป I want to help you to improve your brain นะ Okay. Okay, try the best you can anyway. I just want you to try the best you can anyway. Don't think about score, even though you have some score. But it's very small. Maybe one point only, maybe out of 100. Okay. Okay. But the good thing is improve your brain. Okay. So you solve first, and how you sure that your solution is correct. That's the point. Okay. In real world, actually, you when you solve something, how you make sure that your solution is correct? Okay, not by me. You have to realize when you are when you're working for yourself, you're the one to answer your question, right? Not me. Okay. Try it. Okay. Mônอุปกรณ์สลาธรเพิ่งมาดีกว่าที่จะให้คุณทำงานให้ไปแสดงข้างหน้าจอหาตัวเดียวไม่เจอคุณโผล่นะ0 นะปัญจทิศศาสิทธิ์กิจกรกัญญรัตน์การดีวันนี้ไม่ค่อยได้ยินเสียงกันดีเขมินจักรินชนะชนชยาพลชินนกิจซาร่ายานิสายานิชดาภานดลนรงค์พัฒน์นัฐกิจนัทนิชาแดเนียลธนกรหาเสียง ญธรธาราธีรธรนนทพัฒน์ณนนท์ณนนท์นรุตนิธิเบญจภาเบญจภาอาปณพัฒน์ปวิศลาปวัศิลาปณทัศน์ปณวิทย์ปุณณัฐปุญญธรพลธกรอันภูโอ้โหเรื่องนี้พัสกรพีกตะพลพงศ์พุทธิพงศ์พุทธิมาปาริสภูริพัฒน์มงคลเมทัศน์ยี่เฉินไม่ใช่การใช้ยี่เฉินวณิชยาสรันศิรสิทธิ์สวยางศิรภพสุกิจอาชิระอันติกาเอเอ็นคือเวิร์กช็อป number 2ที่ให้ทำเนี่ยนะ I actually I cannot read what you are what you do so I just check this is okay if not too obvious and put some this handwriting this one something อะไรนะฟังไม่รู้เรื่องว่าพูดอะไรวะ